Hello guys, welcome to the channel. Today we will be doing the question and answer of the second chapter, acid, bases and salts. We will be solving each and every question of this chapter. So let's first start from page number 18, where is a question is asking you have been provided with three test tubes. One of them contains distilled water and the other two contains an acidic solution and a basic solution respectively. If you are given only red litmus paper, how will you identify the contents of the each test tube? So first let us take three test tubes. 1, 2, 3. So then we are provided with a red litmus paper. So always remember the basic solution turns red litmus to blue and acidic solution turns blue litmus to red. So first we dip in these three big test tubes the litmus paper. So we have to follow in which solution the red litmus is turning to blue. So let us take this. B is turning the red litmus to blue, which means it is a basic solution. Then we take out this litmus paper, dry it up, and again put this litmus paper in these two test tubes, and let us see which test tube turns the blue litmus to red. Let us take this litmus is turning the blue litmus to red, so this is a acidic solution, and so this is the distilled water. In distilled water nothing happens because it is in normal state. So now we got to know that A is distilled water, B is basic solution, and C is acidic solution, because we were provided with a red litmus paper. In basic solution the red litmus turned to blue, and in acidic solution the blue litmus turned to red again. So here we identified the three test tubes and its containing solution. Now on page number 22, the first question is, why should curd and sour substances not be kept in brass and copper vessels? Now curd and other sour substances are acidic in nature. Thus when they are kept in brass and copper vessels, acid will react with the metal and bring out the hydrogen gas present in it and harmful products also, and hence will spoil the food kept in the vessel. So how will we write the question answer? Curd and other sour substances are acidic in nature. Thus, when they are kept in brass and copper vessels, acids will react with the metal and liberate hydrogen gas and harmful products, and hence will spoil food kept in the vessel. Now moving to the next question, number 2. It is asked, which gas is usually liberated when an acid reacts with a metal? Illustrate with an example. How will you test for the presence of this gas? Now, when acid reacts with metal, hydrogen gas is liberated. When a few pieces of zinc granules are added to 5 ml of dilute H2SO4 and shaken well, hydrogen gas is evolved. Like we can do with zinc plus H2SO4. So the reaction can be that, and the hydrogen gas liberated can be tested by burning it, as we did in our previous video. The activity was, I guess, 2.1. You can see in the textbook 2.1 figure. You can take it from that, the pop sound example. So the answer will be, when acid reacts with metal, hydrogen gas is liberated. When a few pieces of zinc granules are added to 5 ml of dilute H2SO4 and shaken well, H2 gas is evolved. Now the equation will be Zn plus H2SO4 and the product will be ZnSO4 plus H2 gas liberating. The hydrogen gas liberated can be tested by burning it with a pop sound. You can relate this with the textbook question or the textbook activity in figure 2.1. Now the third question. Metal compound A reacts with dilute hydrochloric acid to produce effervescence. Gas evolved extinguishes a burning candle. Write a balanced chemical equation for the reaction if one of the compounds formed is calcium chloride. So we have to find out that one of the compound is calcium chloride. So starting with metal compound. Now metal compound plus hydrochloric acid is giving us calcium chloride plus effervescence. What is effervescence? Effervescence is CO2. So now, completing the equation, we are getting metal compound as CaCO3. Then HCl in aqueous solution, and the resultants are CaCl in aqueous solution plus the effervescence and water. Next, we come to page number 25, in which the first question states that why do HCl, HNO3, etc. show acidic characters in aqueous solutions while solutions of compounds like alcohol and glucose do not show acidic character? Why? Now, when we dissolve HCl in water, like the solvent is water, when and this gets dissociated in H positive and Cl negative ions, and further the H positive ion gets mixed up with H2O and gives us H3O positive ion. Now when HCl or HNO3 dissolved in water, it forms to form H positive or H3O positive ions, which shows acidic characters or acidic characteristics. Like we have seen here, when you dissolve this HCl or HNO3 in water, it gets completely dissolved. The ions get dissociated with water, and in case of alcohols and glucose, when mixed with water, they do not dissolve to form ions, and they do not show acidic characters. Now the second question: why does an aqueous solution of an acid conduct electricity? Now, as it is an aqueous solution, so water is present in it. Now the answer is, the aqueous solution of an acid conducts electricity due to the presence of H positive ions or H3O positive ions, which are known as hydronium ions. Now the third question is, why does dry HCl gas not change the color of the dry litmus paper? Because here the ions are not in ionized form, or you can say that they are not in a distributed form. So due to the absence of hydrogen or H positive ions, dry HCl gas cannot change the color of dry litmus paper. So the fourth question, while diluting an acid, why it is recommended that the acid should be added to water and not water to acid? So here it has been asked why it is said that acid should be added to water but not water to acid. So here we have two cases. Let us take two beaker. Let us take this as A, this is as B. Now this is filled with water and this is filled with acid. Now here acid is poured drop by drop and here water is poured drop by drop. So it is said this is allowed and this is not allowed. Why? Because when we drop water in acid are mostly vulnerable chemicals. So when we drop water in acid, they react heavily and the heat comes out. So exothermic reaction occurs, for which the glass may get broke. Then the mixture can get splashed and at last burning can occur. So it is said that when we pour acid in water, we should pour it from the edge of the beaker slightly and slowly, drop by drop. That is why this is allowed and this is not allowed. Now if we go through the fifth question, which is how is the concentration of an hydronium ion affected when a solution of an acid is diluted? So how can we make the acid more dilute? Is by adding some more water in it. So when an acid is diluted, the concentration of the hydronium ions per unit volume reduces, which means that the strength of the acid decreases. Now the sixth question, how is the concentration of hydroxide ion affected when excess base is dissolved in a solution of sodium hydroxide? So the question is asked that a solution is given which is sodium hydroxide, which is already a base. So in this case, if we add more base in a basic solution, the hydroxide ions will get increased. Like the answer is the hydroxide ions, which is OH negative ion, concentration would increase when we add excess base in the sodium hydroxide solution. In this case, the base gets more strengthened. That is why the OH negative ion gets increased. Now let's go to page number 28 and check out the first question. The first question is said, you have two solutions A and B. The pH of a solution A is 6 and pH of solution B is 8. Which solution has more hydrogen ion concentration? Which of this is acidic and which one is basic? So now let's take A and B. the pH of A is 6 and the pH of B is 8. Now, as we all know, pH scale, that the 7 is normal, and going this side this is acidic in nature, and going this side it is basic in nature, and the concentration of acidic and basic nature increases by going their opposite sides. Now this is acidic in nature and this is basic in nature. Here the more concentration of H plus ion, and here is less concentration of H positive ions. So you can relate this with the figure 2.1 which I have taught you in the previous class, or if you don't know that, you can go to my last video and check the solution. There you can find out the reasons behind this acidic and basic nature. Now the second question, here you have asked that what effect does the concentration of H positive aqueous ion have on the nature of the solution. The answer is simple. If the H positive concentration or contraction is increased, the solution becomes acidic, and if the H plus concentration decreases, the solution becomes basic in nature. Now the third question, do basic solutions have H positive ions? If yes, then why are these basic? Here this is also a simple question. Yes, a basic solution also has H positive ions, but the concentration is lesser than that of the hydroxide negative concentration, which makes the solution basic. Guys, this is so simple question and answer. These two question answer are related with my previous video in which I have described the figure 2.6, I guess. Yes, 2.6 completely, which is full of acid and basic nature. The topic was how strong are acid or basic solution. You can get the full concept there. Go see that video and learn. Now the fourth question, under what soil condition do you think a farmer would treat the soil of his field with quicklime, that is calcium oxide, or slakelime, that is calcium hydroxide, or chalk, that is calcium carbonate? Now first of all, we all have to know that the calcium oxide or calcium hydroxide or calcium carbonate all are bases. So we have to tell the condition of the soil in which the farmer uses these three: calcium oxide, calcium hydroxide, and calcium carbonate. So as these all are bases, so the farmer is using this for increasing the basicity of the soil. Because of the acidic nature of the soil has become infertile. So the answer is to increase the basicity of acidic and infertile soil, the farmer treats it with quicklime, slicklime, and chalk. Next, we are going to page number 33. First question. So the first question is, what is the common name of compound CaOCl2? What is CaOCl2? CaOCl2 is nothing but bleaching powder. When chlorine reacts with the calcium hydroxide, we get the product CaOCl2. Now how it is formed? I will show you. Cl, chlorine, plus CaOH2, which is calcium hydroxide, gives us the product CaOCl2, which is bleaching powder plus water. Now the second question. The second question is, name the substance which on treatment with chlorine yields bleaching powder. The substance is calcium hydroxide. Now you can check here, the substance is calcium hydroxide. Number third question. Name the sodium compound which is used for softening hard water. So the answer is washing soda. Washing soda is used for softening hard water, and the formula is Na2CO3 10H2O. But how do we get to know that the water is hard or soft? Whenever we wash our hands with soap, it forms lather. Then the water is soft, and if it doesn't form lather, then it's hard. Now hard water is not good for health. Even for clothes also it is not good. So to make the hard water soft, water softeners are used. There are many types of water softener, and a type of sodium compound is used that is known as washing soda. Now the fourth question. What will happen if a solution of sodium hydrocarbonate is heated? Give the equation of the reaction involved. Now formula of sodium hydrocarbonate is NaHCO3. Now when we heat the sodium hydrocarbonate, we get NaHCO3. Heating, this is the symbol of heat, we get Na2CO3 plus H2O plus CO2 releasing and balancing the equation. This comes up to here. Now the fifth question, write an equation to show the reaction between plaster of Paris and water. Now plaster of Paris has a formula CaSO4 into half H2O. Now the reaction equation, that is CaSO4 half H2O plus H2O will give us CaSO4 into 2H2O, which is, this is gypsum. Now when we balance this equation, we get CaSO4 half H2O plus 1.5 H2O gives us CaSO4 into 2H2O. Here balancing this equation, we have added 1.5 H2O in this. Okay, now the result is that plaster of Paris reacts with water to form gypsum. So guys, we are ending the video here because the last video was too long. It was almost of 1 hour. So now I have decided to divide the mid-chapter questions and the exercise question. So in this part I have done all the mid-chapter questions, and in the next video I will be doing the exercise question. Hope you like the video. So encourage me by clicking on the like button, and do not forget to subscribe, because subscribing keeps me going. Thank you.